Alright, I'm going to demonstrate how to use Thaiphoon burner to correct issues with memory configuration errors, as well as add an XMP performance profile. So if you open up Thaiphoon burner, you can read directly from the memory chips. We have 2 sticks in here, so if you notice that red from the stick on the first slot, and this is the Team Group Vulkan memory. This is the 16 gigabyte modules. One thing I'd like to point out that's an error, if you look in CPU-Z on the SPD tab, the XMP profile should be CL22, and if you try to set the XMP1 profile on the BIOS, the system will not boot. That's because it's been configured wrong. If you actually look in the BIOS on the SPD section in the memory area, it shows 15, and if you'll notice here, 15 is not even one of these choices here. So what they've done is they forgot to configure it. So these are the timings that are trying to be applied to 3200, and that should be for 2133, and the system will not boot at all with the XMP profile. So here's how we correct that. This little wrench icon right here is for the XMP editor, and if you notice it has 22, 52, that's what it's supposed to be, but there's no check mark here. If we look through this, through these CL latency things, none are checked until we get down to 15. That's why the system's not bootable using the stock XMP profile. What we have to do is remove that check mark in the supported box, change this back to 22 as it should be, and add the check mark. At this point we can click apply, and it will apply it to what's showing in the window here, but it won't apply it to the memory module. Since both of the memory modules are messed up, we can write this to both memory modules at once using this window that's open here by just clicking Program Options, write the new SPD data to EEPROM, and we could select individual sticks, or we could write it to both and click Apply. You'll see it's down here at the bottom where it's writing to each stick. Now it's writing to the second stick. So if we read from one of the sticks again and we go back over here, we'll see that 22 has a check mark on it now, and this RAM would now be bootable. You'd need to go into the BIOS, change it to like custom profile, reboot, and then go back in and change it to the XMP profile. You have to change it from default or custom in order for the BIOS to get new data off of the sticks. So this has made a permanent change on the memory. We can write the entire capacity of the memory using this area, using both the read and the write, but I caution you doing that. You should always make a backup of the original SPD, and also each memory module has a unique serial number. If you see this one here, now and this is bold, the stick that I read from, if I read from this other stick, the serial number is going to be different. So you see there. So what you really need to do is take a backup first from each stick, make note of the serial number, and when you save it, what I like to do is just copy and paste. So if I copy that, that's the serial number on this stick. I'm going to come over here and use Save Dump As, and I need to make a new folder here. These are the 16 gigabyte sticks, so I'm going to call it TG Vulcan 16 gigabyte stock SPD, and these have Hynix modules on it. That's important because some of them are Micron and some are Hynix. So if I click in here, hit my home key or my arrow, and I'm just going to copy and paste the serial number right in there so I know that that's the firmware that I saved from that stick. I'm going to read from the other stick. The serial number is not that important. It could be for warranty purposes, but you don't want to have the same serial number on both sticks. On some systems, it will prevent it from booting correctly. Yeah, you may just end up with a black screen if they're both sticks with the same serial number. So you could make the serial number anything that you wanted to, but they need to be different. They can't be the same, or at least on some systems they can't. So there, I've saved that. And if we come over here and look, we've got a backup of both of the memory modules, and both of those backups are fixed because we added the check mark to the CL22. Now let's look at adding an additional XMP profile. This profile is what comes from the factory. It's kind of meh, it's alright, but it's kind of slow, really sloppy loose timings. What we're going to do is we're going to program 3200 CL16, and I actually already have a profile saved that I'll make available to you. And if you click on the user templates, and here you'll see Team Group 3200 CL16 Mr. Fox. That filled that window. It was blank before, and now it's got a check mark that it's enabled. You do need to change this from 1 DIMM per channel to 2. That way you can put 4 sticks in and it would work alright. You can adjust the default voltage here if you'd like. 1.35 should be enough for 3200 CL16. It has been on the 8 gigabyte 6. So I will test that, and if it's stable, passes memory test with no errors and boots okay and everything, I'll leave it at 1.35. If it boots okay but has some errors in memory testing, then I'll come back in here and I'll change it to 1.4 volts. But for right now, that's fine. So I'm going to apply this to both sticks the way I did after correcting the CL22 problem with the missing check mark before. And if you notice down here, we got 1600 megahertz, which is 3200, 1600 times 2, CL22. I'm going to click Program Options, write the new SPD data to EEPROM. I'm just going to go ahead and write it to both sticks. Click Apply, and now it's writing to the first stick, and then it's writing to the second stick, and you see that we have 2 XMP profiles now. One thing you want to always be careful of is that you see there's no cyclical redundancy errors, CRC errors. This is green here, it says OK. You can also look over here where it says Report, and you'll see right in here it shows that it's OK. So that's that stick. We can see that it's OK. For the checksums, check the other stick. Both are OK. If you see errors, the memory is going to give you problems and not going to work right. And you can see now here that we've programmed both. We corrected the error on profile 1, and we've created a new profile 2 that's faster with lower latency and slightly higher voltage. And that's it, we're all done. So what we probably want to do now is we could save a backup copy of this, right? So let's come over here. Let's go into my Thaiphoon burner folder, my Team Group folder, and I'm going to make a new folder and call it Team Group Vulcan 16 gigabyte mod SPD, and it's Hynix chips on it. And we'll go ahead and put a backup for each stick in there. So let's read from the first stick. Everything looks good. We got both profiles. We got green down here. Let's copy and paste our serial number for this stick. Oh, wrong folder. This folder right here. Paste the serial number. And I'm going to call this mod. And I'm going to make sure we know that it's Hynix. So we've got a backup from that stick. I'm just a fan of making backups. In case something goes wrong, you can always undo it without having a mess. So we're going to save it with the same name other than the serial number at the beginning. There's the new serial number. And there we go. We've got a backup from each memory stick. And that's it. Pretty simple, right? So a problem that I found with all of the Vulkan, Team Group Vulkan memory sticks, regardless of what denomination they were, is that the XMP profile from the factory is broken. It's not proper. If you look at what the XMP profile shows, it should be the same as the JDAC, meaning it's 2222, 2252, right? If you set XMP, it will not boot in almost every case. If you can boot one stick, it'll boot, but it boots up at 2133 with CL15. And the reason being is, as I showed a moment ago in the video, the XMP profile is not configured to run at CL22. It's got the check mark in the CL15, which if you look in the SPD table, that's for 2133. And that's exactly what happens if you can get it to boot with two sticks. Most of the time, I was not able to get the system to post. If I set the XMP profile, I had to clear NVRAM. Fortunately, I was able to capture that in this, and it also shows that way incorrectly in the BIOS as well. In order to capture that, what I'm referring to in the BIOS, I'll have to use some photographs to do that. If you notice, XMP1 is showing it's set for 3200 at CL15, which is not bootable. The only time the machine will actually post correctly is if it ignores the 3200 and boots at 2133. So this is what you see in the BIOS before we take the steps that are necessary to fix that factory XMP profile. It's really messed up. Once you've programmed memory and you want to switch to new sticks, let's say that you have a customer's machine and you've programmed the Thaiphoon burner with a custom XMP profile, or you've repaired this broken factory XMP profile. In order to get this new information recognized, you're going to have to switch from the default profile that the system boots up with, and when you go into the memory section in the BIOS, you'll see default profile as I show here on the screen. You'll need to change that to custom profile. I also recommend on the custom profile that you change the memory voltage to 1.35. 1.2 volts is just barely enough for the system to boot at 3200, even with the sloppy loose CL22 timings. So if you don't switch the voltage, it may still boot. I did run into difficulties, especially with the larger 16 and 32 gig sticks, where it had a difficult time booting correctly with 1.2 volts. So if you switch that to 1.35 volts, that should get you in business. After you've switched it, you'll actually see it change from 1.2 volts to 1.35 here. Once you've done that and the system boots correctly, when you go back in to the BIOS, you'll actually see correct values here. It'll show the factory profile that's fixed. It'll show 22, 22, 52, just as it does here. It'll show exactly the same numbers here. And if you've added a custom XMP profile, it'll show here in the XMP2 slot as well. So I hope that makes sense with these photographs showing you how to do that. Otherwise, unless you change from default profile to custom profile, the BIOS, when you boot up, the BIOS doesn't stop and read the information from the sticks because nothing's changed, so it ignores any changes, and that's why you would not see a change here unless you paused and changed from default to custom profile. Or if you were on custom profile already and changed back to default, it would do the same thing. Because of the disruption in settings, it would cause the BIOS to stop and read what's on the sticks. All right?